Welcome back. We want to use MATLAB to illustrate what happens for the simple experiment of tossing a coin 100 times. So you can see n equals 100. We're going to assume that we have a fair coin. So P, our probability of success, is 50%. We'll assume getting a heads is a win and a tails is a loss. So it's a 50-50 chance. And then we have two new numbers here. A equals 45 and B equals 55. So what we're actually doing with this simulation is we're going to see what is the probability of getting between 45 heads and 55 heads out of 100 tosses. So we know that 50 is the most likely outcome, but simply getting 50 is fairly unlikely. We want to figure out what the probability of getting between 45 and 55 will be. Okay, so let me run the simulation. Let me open up my figure window just a little bit more and run this simulation. And you can see our binomial distribution histogram here. These are the theoretical probabilities, not from an actual experiment, but theoretically, this is what it should look like. And when I ran it, you could see how it shades in some of those bars in the histogram. The bars that are shaded in are the ones that correspond to 45, 46, 47, and so on, up to 55 heads being tossed out of the 100 tosses. So there's a reasonable probability that we wouldn't have that happen, but you can see up at the top in the menu, in the title, the probability ended up being 72.9% roughly. Okay, so and that actually corresponds to the area of the bars. All right, each one is 1 unit wide. So if we add up the frequency for which something happens, the area of these bars is roughly 73% of the area under the entire histogram. Okay, or so the area that's shaded in is 73% of the entire area of the histogram, right? So we could answer that quickly. By the way, let's just look at what is the probability of actually getting 50 heads. I would have both A and B set at 50. And while getting 50 heads is the most likely outcome, we can see that it's about an 8% chance of actually landing at exactly 50 heads. If we were to expand that out to maybe going from 48 to 52, that's more approaching 40% probability. If we go from 47 up to 53, our probability should be growing. The probability of that is just tipped over the 50% mark. So if we include the 47 and the 53 in there, the probability of getting anywhere from 47 to 53 heads is about 50-50. So the probability of getting anywhere from 45 to 55 is significantly higher the way the histogram drops off. And so when I look at that probability, it's about close to 73%. Okay. Now, in the last video, we were looking at how we could, instead of using this histogram, perhaps we could use the normal distribution curve. And we had looked at what that shape would be, the bell curve. All right. The reason we might want to do this is to do the calculation by hand. There are 11 bins in the histogram between 45 and 55. So if you were to start counting on your fingers, making, your first finger is 45 and you go to 55, you would need 11 fingers to do so. So anyhow, we might be able to use a bell curve to do the same thing. So I want to switch over to a normal binomial calculator. So it's using a bell curve to approximate what we have here. Okay, so let me run this again and let's figure out, okay, so n is 100, the probability is 0.5, and we were looking for getting anywhere from 45 up to 55 heads. We're going to figure out the probability of that happening. So let me run this. Okay, you can see, oh, let me make the bell curve a little bit. Change the scaling of this. I'll go 0.15, so it's a little taller. We'll be able to see it a little bit better. Right, so if I look at the area that's shaded in under the bell curve, which is something easy to do once you learn calculus, we can see that the answer is not quite what we expected. It's 68.3%. Now, there's a reason for that. If we would go back to our binomial calculator, right, it's not so obvious, but the bar that is at 45 successes actually straddles from 44.5 up to 45.5. So the bars, we can see it better if we cut our numbers way down. So if I change n to something like 10, and I say, what is the chance of getting between 4 and 5 heads? We can see that each bar, while it's centered on the number of successes, it straddles from half below that to half above that. So if you look at the 4, it straddles from 3.5 up to 4.5. The bar that's at centered on 5 goes from 4.5 to 5.5. So in order to get a better measurement using the normal distribution curve, instead of finding the probability of being between 45 and 55, we need to find the probability of being between 44.5 and 55.5, because that's the part of the curve that would correspond to the bar graphs from 45 up to 55. I should say the histogram bins. Okay, and you can see suddenly the area, the probability went up to 72.9%, which is a very, very close match to what we had determined using the histogram. And it's a far easier calculation to do once you've had calculus, right? So statisticians would prefer trying to figure out probabilities, especially when the sample size gets very large. It's much more efficient to use the bell curve rather than trying to use the binomial distribution. When the sample size is small, you probably want to stick with the binomial distribution, but when the sample size gets large, the bell curve is better. In fact, my bell curve, I don't believe, will crash if I went out to 1,000 and went back, and let's just add some zeros in here just to make it work. The bell curve works just fine for that, okay? So the bell curve works very nicely when we get up to very large numbers, whereas the binomial distribution is better to work with for small numbers, but you wouldn't want to have to calculate by hand all of the possible bins when you get up to large numbers of bins, right? So this probability distribution approximates, and the bell curve gives us an extremely good approximation of what would happen. And we can see that the probability of getting between 45 and 55 heads, if I make that little adjustment of the half steps, is in fact 72.3%, right? Now, you all don't have MATLAB, but you do have calculators. You can do this very same calculation on your calculator, right? There are just a couple of things you need to know, all right? When you use your calculator, you need to know an average value and you need to have a standard deviation. So it may be fairly obvious that the average value is simply the number of attempts and the probability for success. So in this case, if I have a 50-50 chance of getting heads and I toss the coin 100 times, my average number of heads should be 50. All right, that's what it means to have a 50% probability of getting heads. If you were to toss it 100 times, you'll get 50 of them. But the standard deviation is not quite as obvious. It turns out, for reasons that you wouldn't understand yet, they're a bit complicated and they need to be derived using calculus. The standard deviation is given by the square root of the number in the sample times the probability for success, times, remember 1 minus p is the probability of not succeeding or failing. So in the example we have here, let's just calculate what that would be in the command window. If you had 100 attempts at tossing a coin, we would want to find the square root of 100 attempts times the probability of success is 0.5 times the probability of failure is also 0.5. And so, whoops, when I misspelled, there we go. I just had a spelling error, and we can see that the standard deviation for this experiment would be 5. So we know that the average is 50 and the standard deviation is 5, and we want to find the probability of getting between, we'll say 44.5 and 55.5 heads. Okay, so how do we do that on our calculator? Let me pull up the iPad and step you through the instructions for that. Okay, so I've written down what we had established. We want to find the probability of getting between 44.5 and 55.5 heads out of 100 tosses. We need it because of the way the bins fall. We need it, instead of putting 45 to 55, we have to recognize that we're, the bins would straddle that from the halfway marks. Okay, so this is what we want to put into the calculator, right? But it turns out there's a command on the calculator that finds the area of the bell curve, all right, between two values. So let's use that command, all right? So to do that, the buttons you have to push are, go with the second button, which is actually in blue, and you're going to look for the variables button, VARS, and right above that is the word DISTR, that stands for distribution. So we can calculate distributions like the normal distribution if I go ahead and use that. Okay, so now when you hit that, you're going to see a couple of options pop up. Option 1 is normal PDF with a parentheses. That's not what you want. You want option number 2, which is normal CDF. I think the C has something to do with combinations, so that's what you want to choose. So actually have your calculator out. Pause the video if you don't. Get your calculator out to practice this. And start once you have your calculator. So then hit enter on number 2, right? And you will see a lower value comes up. In this case, our lower value is 44.5. Then upper value needs to be typed in this case, 55.5. And then it's looking for, it has a mu, okay? That is the statistic symbol that often is used for the mean. Okay, so we're going to put in 50. That is the symbol for mean in statistics when you have an entire population. And then it has a symbol sigma, all right? And that is used for standard deviation for a population. So we want to enter the number 5 for our standard deviation. And then paste. You want to go down and choose paste, and it will paste your result into sort of the working window of your calculator, and then just hit enter one more time, and it will give you the probability that we just spoke about. Okay, so the number that comes up is going to correspond to 0.7287 if I round it off, which is 72.9%. Okay, so make sure you understand what that's giving you. That's taking a bell curve, which is centered on 50, and it's going down to 45.5 and up to 55.5. So those are those other two numbers you entered. 55.5, and it knows that the standard deviation, okay, so the amount that this bell curve spreads out is about plus and minus 5, okay, around the mean. So the standard deviation values are just at 55 and 40, I'm sorry, this number here was 44.5. Okay, so just inside of those is where one standard deviation would be. And so knowing how, what the standard deviations are, it knows how wide to make the bell curve. And then it shades in and finds, it's actually finding the area that would be between those numbers under the bell curve, just like I showed you in MATLAB. So it doesn't give you a visual representation of it, but it very, very quickly gives you a result. So that's how you can work with your calculator.